How you going, guys? Kurtis from Cutting Edge Engineering. Today's job, we're going to be repairing a top cap and a bearing mount off a front strut from a 785 dump truck. So this cap is mounted on the top of the suspension strut. Not only is it the suspension, it is also the main steering joint for the truck, and the bearing mount is put over the top of the spigot and mounted onto the truck to help support everything during operation. And there is a spherical bearing installed into the mount, and that is there to allow movement between the top chassis and the bottom chassis when the component is fitted. It is very common for these to wear out just because of the general nature of where they are and what they are doing, but one of the biggest reasons for these components failing is incorrect fitment, where the mount isn't actually shimmed away from the top chassis correctly and they wear out or they break off. Fortunately, our customer caught this before it completely failed and broke, but there is wear on the spigot and the bore of the mount, so we're going to be reclaiming both of them. And we are going to be doing two different methods of reclaiming. The strut cap is made from steel, so it can be welded and machined back to spec, and the mount is made from cast iron, so we'll be boring that out and putting a sleeve in it. We're going to get started with the strut cap, so we're going to get it set up in the lathe. Because we already have a couple of videos on our channel on repairing the top cap, we're not going to get into too much detail on how we do it. We're just going to get this machine down so we can weld it. It's hard.
That sounds so hard.
So straight away I can tell this has been repaired before, and they have used metal arc spray. Not only is it extremely hard and the sound that's coming out of the cut, there is also a very distinct colour of swarf that is coming off it. Not only that, we can see the existing thread pattern that was machined into it before it was sprayed. And because of how hard that metal arc spray material is, I've already worn out my insert, so I'm going to flip it to a new tip. So it looks like this has had a second repair done before, and I can tell that by the pattern left on the area we've just machined, but that time it had been welded. So that has cleaned up, but I am going to take a third cut, that way we get a good build up with our new weld layer. There's a crack there.
Oh, what?
Yep. So I've got that machine to the size I want, but I have discovered a crack in the base of the spigot. So what I'm going to do is put in a button insert and machine that out and see how deep it goes. So we have successfully machined to the base of that crack. If it had gone any further, it would have been a better option for us just to machine this out completely and replace the pin entirely. But now what we're going to do is get this out of the lathe over to the welding area so we can weld it up. So I'm going to be using our welding stand with our Sir Meccanica to weld up the spigot, but before I can do that I need to weld up the area that we machined out to find that crack. But first I'm going to give it a preheat. What I'm going to be using is CIG vertical in a 1.2. It is a dual shield wire. We'll use that to fill that area. I'm just going to grind down any of the high spots, that way it doesn't interfere with the new weld layer we put over the top of it. Now with that done, we can get it set up to weld the spigot.
You're so silly. Hey, what you got? That's your pig. Hey, where's your pig? Where's your pig? You left it behind. Go get it.
The welding wire we're using is ER70S6. We weld repair the spigots on the top caps because it is a far quicker and more cost-effective method than metal arc spraying. Now that we've got that welding, we're going to get started on the bearing mount. To set it up, we're just going to be using 2 angle plates, so we'll get all that bolted down and then we'll find center of the bore. To bore this out, we're going to be using our adjustable boring head and a CCGT insert.
Going the wrong direction.
So I've got about 9mm of material to take out of the ID, so I'm going to rough it out so we can get a measurement. So I've taken our roughing cuts and we've got a measurement, and we have 1.7mm to remove. So I'm going to advance the boring head 0.85 of a mil and take our finished cut. So that's cleaned up really nicely, and the welding on the top cut is about to finish, so we're going to go keep an eye on that. Righto guys, so the welding is completed on our spigot. I'm really happy with how that came out. We're going to have to let that cool down for a while, but while we're waiting, we're going to get onto it machining up our repair sleeve for our bearing mount. George.
Oh.
For our repair sleeve, we're going to be using ST52 tube. It is a 5.5-inch OD with a 5-inch ID. We've got about a mil to come off the OD and about 4 mil to come out of the ID. The finished ID we're aiming for is 139.1, which will be a 0.1 interference fit in the bearing mount. So that's not machining very nicely. I'm going to change out to a finishing insert, which will give me a far better surface finish. So I've taken my measurement and I've got 0.16 of a mil to remove. Yep, just made it. So that's measuring at 139.11, which means we are 0.01 of a mil larger than we were aiming for, but that's going to be fine. That just means it's going to be a slight tighter fit. So now with the ID done, we're going to bore the ID. So I'm going to be machining the ID to within 1 mil of its finished size, and once the sleeve is fitted into the bearing mount, I will finish machine it to spec. So I'm pretty happy with that. Now what we're going to do is chamfer the edges and then we can cut our snap ring groove. To cut the snap ring groove, I'm going to be using an internal grooving tool with a 4mm insert. So with that cut, now what I need to do is part it to length. Now that we've got that done, we can fit it into our mount. Typically, I would be using liquid nitrogen to freeze down the sleeve to fit it into the mount. Unfortunately, we have discovered that our dewar has got a break in it and it is no longer holding a vacuum, which means any liquid nitrogen inside just continues to burn off. So we don't have any liquid nitrogen to use. So what we're going to be using is thermal expansion. We're going to be using the oxy to heat up the mount to get it to expand, and we can then install our sleeve.
No. Nope.
I also prefer to use liquid nitrogen on a job like this because it means I can machine the sleeve to size, allowing for the crush on the bearing and in the mount, because it doesn't distort when it gets back to room temperature, where with heating, metal can do some really weird things when you heat it up, and by leaving that 1mm material in the bore to finish machine, that eliminates any problems that I may run into if the material pulls out of shape or gets distorted. Now that's fitted, we need to let it cool down, but our strut cap is now ready to be machined, so we're going to get onto that. Now we've got that set up, we're going to machine it down to suit the ID of the bearing, which is 3 1/4 inches or 82.56 mil. Righto guys, so that's the repair on our top cap completed. I'm really happy with how everything worked out. I'm just going to coat it in grease and wrap it up so it doesn't rust. And now the bearing mount's cooled down, we can get it set up and finish machining that. Now we've got that set up, we're going to take a clean-up cut to get a measurement. So I've got 0.4 of a mil to remove. I'm going to advance ahead 0.2 of a mil to take our final cut. So that's measuring spot on, and that gives us our 0.1 of a mil crush on that spherical bearing. I'm really happy with the surface finish on that. All I need to do now is drill in the 2 grease holes. And we're not going to be fitting the bearing because our customer is going to sandblast these before they get reassembled. I'm also going to apply grease to the bore of the bearing mount and wrap it as well. So that's this repair completed. We're going to get these on their way to the customer. Thanks for watching.
It won't even focus.
To cut the snap ring groove, I'm going to be using an internal... To cut the snap ring groove, I'm going to be using an internal grooving tool with a 4mm snap... To
cut.
I don't make anything easy for Karen. So typically in...
Wow.
So that has cleaned up, but I am going to take a cleaned up third cut. So it looks like this has had... So you fucking smile. So it looks like this has had a second repair before, and I can tell that by... Let me just start again. No, don't start again.
Just start again.
Just give me a moment. I try not to listen to it. Now I'm noticing it more. I hear it all day. Right. So fuck you. Okay. Oh, where is it? So I'm just going to get it positioned under the... Anything else?
Here comes the quick change.
Hold on to your hats, everybody.
You and your freaking...
I need more holders.
You got more. What are those for? Oh, they're boring bowls. No, there's an empty one just there. Kurtis.
$139.11. So it's 0.01 of a mil tighter than it should be.
So is that good?
Yeah, well, it's better to be tighter than looser.
What are you doing?
I need to pick it up to wrap
Then
in
do
there.
that. Stay. Stay. Good boy. Okay.